1/10 of our Earth is covered with ice, but it is melting at a rapid pace with catastrophic consequences, deadly tidal waves, pandemics caused by primeval pathogens.
Obviously, we are quite resistant to viruses that our organisms know, but these are old viruses that no living creature has encountered before. So we are in uncharted territory here.
The worst case scenario, the climate tips towards a new ice age.
So if there was lots of ice loss, then the Gulf Stream, which provides heat to North America and Europe, might start to shut down. If it shuts down completely, there'd be a really big change in the climate in those regions, and would there be a return to something like Ice Age conditions.
Our only chance to prevent such disasters: state-of-the-art satellite technology, DNA analysis, and gigantic underwater structures.
Preparing ourselves for the melting of ice is probably one of the biggest challenges as a human race that we face.
A race begins in which no one knows who will win. Chapter 1, the threat of melting glaciers. Can we prevent killer mountain floods in the future? Chapter 2, thawing permafrost. How prepared are we for pathogens from the eternal ice? And finally, Chapter 3, melting polar ice sheets. Is there still time to avert a climate catastrophe? Let's find out on Facing Forces of Nature. For many millions of years, a natural alternation between warm and cold periods has greatly impacted our planet.
So we get periods of cold and warm climate naturally on Earth. This is related to things like the orbit of the Earth around the Sun. We sometimes move a bit closer to the Sun, we sometimes move a bit further away from the Sun, as well as greenhouse gases, which in the past have come through natural sources, so things like volcanoes and also absorption into the oceans, and in more recent years, because of human activities.
100,000 years ago, during the so-called warm glaciation period, an ice sheet measuring up to 3 kilometers thick lay over Europe, Asia, North America, and parts of South America. 10,000 years ago, as temperatures rise around the world, a natural warm period begins. Large sections of the ice sheet melt. In the mountains and colder regions of the Earth, such as the Arctic and Antarctic, some of the ice remains. Following a natural rhythm, it's a climate that will actually persist for tens of thousands of years more. But since the beginning of industrialization, man has been increasingly influencing the climate. 250 years ago, people began to burn fossil materials such as coal, wood, and oil in large quantities, thereby releasing gigantic amounts of CO2 and methane.
So since the beginning of industrialization, the CO2 and methane content in the atmosphere has nearly doubled. So we clearly see that this is triggered by human activity.
Greenhouse gases allow sunlight to enter the Earth's atmosphere and prevent it from leaving. If there are too many greenhouse gases, too little heat is released and temperatures on Earth rise. In the last 100 years alone, average temperatures have risen by 1.2 degrees Celsius. The consequences? Ice masses are rapidly melting. Within 23 years, mountain glaciers have become a good 6 trillion tons lighter. $7.6 trillion tons of Arctic sea ice have melted, and the polar ice caps have shrunk by more than 12 trillion tons of ice.
At the moment, the Earth is losing something like 1.3 trillion tons of ice per year. To put that number in context, a piece of ice the size of Mount Everest would weigh something like 1 trillion tons, and we're losing that much ice every single year. So you can imagine how much that is when you think about the fact that humans have been heating the globe since the start of the Industrial Revolution almost 200 years ago now.
Melting ice threatens to unleash disasters that make entire tracts of land uninhabitable. In the year 1892, a glacial lake on Mont Blanc in France overflows, blowing away its banks. A 12-meter-high avalanche of water, mud, and debris shoots down into the valley, destroying a mountain village. Some 200 people perish.
So back in the days of this disaster, the population was really small. But today, there's so many more people living there, so the magnitude of the event would be so many times bigger.
Often, the danger is not even visible to the naked eye. In 2016, there's an anthrax outbreak on Russia's Yamal Peninsula.
In Russia in 2016, there was an anthrax outbreak that was associated with melting of the permafrost. As the permafrost melted, these bacteria that had been lying dormant were released into the atmosphere and people were infected. Anthrax is an incredibly dangerous disease and many people were hospitalized by this outbreak.
But all this is nothing compared to the ensuing disaster. 12,000 years ago, melting ice masses bring the Gulf Stream to a halt, altering the global climate. The average temperature in Europe drops to -4 degrees Celsius.
So if the Gulf Stream dries up, we would get a much colder climate in the latitudes we're living in Central Europe and Scandinavia.
If we fail to stop global warming, the only chance to prevent such catastrophes from happening again is advanced technology. The battle, man against the forces of nature, begins in the mountains. About 800 satellites are watching the Earth and discovering more and more new glacial lakes.
When a glacier melts, it sets free the water and also debris that was trapped inside the glacier. This material has to escape to somewhere. If there's nowhere to escape to, then basically it accumulates and forms a glacial lake.
Together, all known glacial lakes worldwide have a volume of 156 cubic kilometers of water. If this amount of water were transferred to oil tankers with the tankers lined up in a row, it would reach around the Earth a whopping 47 times. If all these tankers were filled with oil, that would take care of the world's oil consumption for 27 years.
Glacial lakes are really dangerous. They are dammed up, but if the dam breaks, they can trigger devastating flooding downstream.
The banks of the lakes are made of boulders of ice and act as natural dams. They are stable, but only to a certain point. If too much meltwater from the glacier flows into the lake, the dams burst. The result is a so-called glacial lake outburst flood, or GLOF for short. It's a gigantic tidal wave that carries away mud and debris, destroying everything in its path.
Of course, the glacial lake outburst floods are much more likely now with the melting of ice than they were in the past.
Radar satellites are used to locate these glaciers and lakes. They constantly circle the Earth, emitting radio waves. Their antennas intercept the reflections. The time span and intensity of the reflections provide information about the nature of the Earth's surface and how much it changes. The problem: the satellites can spot potentially dangerous glacial lakes. But when it comes to more accurate predictions, their surveying technology reaches its limits.
Satellites are at a great distance outside the atmosphere, because if they were too close, at 500 kilometers or less, they would basically start to burn up. Their orbit would degrade due to the friction of the atmosphere. And to prevent that from happening, you need a lot of fuel. So the satellites which are launched are usually put into a higher and safe orbit that costs very little fuel. But the cost that you then pay is that your resolution of the images is much lower.
The next step is monitoring directly at the lake. Like at Planmort in Switzerland, Lake Faverges has burst its banks several times, flooding the villages in the valley below. For several years now, a sophisticated early warning system has been in place there. Pressure sensors are sunk in the middle of the lake. Via cables, they constantly transmit information to a solar-powered measuring station at the edge of the lake. If the sensors notice a change in the lake's water pressure, the measuring system automatically triggers an alarm. In addition, a rotating camera monitors the situation. The camera scans predefined positions several times a day, providing an overview of the entire lake and its immediate surroundings.
If you monitor the lakes, you can probably have a pretty good idea about how big an outburst flood is going to be. And if you know how much water is going to be flooded, then you can maybe have a good idea of the measures that need to be taken to protect people. If this is going to be a massive outburst flood right near, say, a town or a city, extreme measures might need to be taken.
The problem is, if the glaciers melt, it affects the entire mountain landscape. The ice acts like a glue, holding layers of snow and rock together. When the ice melts, these layers become loose. The result? The glacier collapses, like those in the Italian Dolomites in the summer of 2022. Temperatures in the mountain region had been 10 degrees higher than normal for days. The snow and ice melted at record speed. It's too much for the glacier. A huge piece breaks off. An avalanche of ice, snow, and debris forms and thunders down into the valley at a speed of 300 kilometers per hour. 11 climbers die. Another 5 are seriously injured.
These catastrophes are going to become more frequent, and that just goes to show the human cost of climate change.
One of the largest glacial lake breaches ever occurred here in Kedarnath, northern India. In 2013, meltwater and monsoon rains filled the Chorabari glacial lake in the Himalayas to the brink. The natural dam holds until a slope above the lake, a gigantic avalanche of snow, like this one, cuts loose and plunges into the lake. The pressure is too great, and the lake's walls are catapulted away. Within minutes, 260 million cubic liters of water rush into the valley, creating a meter-high tidal wave of water, mud, and debris. 6,000 people die. 100,000 lose their homes. In order to predict such a disaster in time, another state-of-the-art system is being utilized, so-called interferometric georadar. From a distance of 4 kilometers, the radar can monitor an area the size of a football field.
The big advantage of these kind of methods is that they're indirect, so you don't have to physically be there. That's a really big advantage because these are hugely dangerous places.
If the measurements exceed critical values, the system triggers an alarm. This allows scientists to predict rock slides practically down to the minute.
These are forces of nature that no human being can really beat. So the best you can do is get an early warning to get people out of the way and any infrastructure, protect any infrastructure that you need.
The only way to prevent a flood from a glacial lake is to lower the water level in the lake. Just a few years ago, Lake Imja in the Himalayas was considered to be one of the most dangerous glacial lakes in the world. In just 20 years, it has grown 3 times its size.
So this lake was so dangerous because it could have an outburst any minute and then flood the entire valley.
To prevent this, the government is building a 7-kilometer-long walled canal from the lake to the valley. A sluice regulates the flow of water directly on the lake. Thanks to the canal, 4 billion liters of water can flow out of the lake in a controlled manner. Today, the water level is 3.5 meters below the dangerous maximum level. In the Peruvian Andes, a different system is used. Below Lake Palcacocha lies the town of Huaraz, with a population of 120,000. If the lake were to breach its banks, it would take just 35 minutes for the masses of water to reach the city. In 2009, the government built a drainage system from the lake to the valley. When the water level reaches a critical level, water automatically flows into the pipes and the lake empties again. Thanks to modern satellites, high-tech on-site monitoring, and various drainage systems, we can currently control the dangers posed by glaciers and glacial lakes reasonably well. Anyway, melting ice is a danger not only in the mountains, but also in the northern hemisphere. 23 million square kilometers of our planet are permanently frozen. It's called permafrost.
Permafrost is defined as soil that is below 0 degrees for at least 2 years in a row, and the freezing can reach down to 1.5 kilometers.
The planet's vast permafrost regions, such as Siberia or Alaska, are sparsely populated, but all the more important for industry. 10% of the world's oil and 25% of the world's natural gas come from permafrost regions. In addition, gigantic deposits of gold, diamonds, coal, and rare earth elements lie in the permanently frozen soils. But the ground that has been frozen for thousands of years is gradually thawing due to global warming. In the last 150 years alone, 12% of the permafrost has permanently thawed. If you take one of the largest football stadiums in the world, Munich's Allianz Arena, It would fit more than 3.5 million times into the area of permafrost that thaws per decade. An area as large as the whole of Greece. In Alaska alone, the consequences are catastrophic. Collapsing buildings, roads, and pipelines, causing hundreds of millions of dollars in damage per year.
Calculations show that the permafrost could be actually gone by the turn of the century.
The world's vast permafrost regions have remained virtually untouched for millennia. It wasn't until the end of the 19th century that the first mega construction project on permafrost was built, the Trans-Siberian Railway, a 9,300-kilometer-long train route across Russia. But shortly after completion, the first sections of track collapse. This is because the top layer of the ground thaws in the summer, only to freeze over again in the fall. Engineers are now just learning how to build stable structures on permafrost. In fact, in Siberia, the first large cities are sprouting up in the middle of nowhere, at first according to classical construction methods.
After the Second World War, it was discovered that the eternal ice, the permafrost, was actually hiding valuable resources, oil and gas resources and minerals. And so there was an interest in, a natural interest in exploiting these. But at the same time, it was discovered that these are regions of strategic importance by the US and the Soviet Union. And therefore, the two powers, in a way, the politics influenced the science here, or drove the science, in that the two powers therefore set up systems to give early warnings of the permafrost melting.
The great breakthrough came with the pier construction method, developed by a Russian engineer. Several rows of meter-thick concrete piers are virtually frozen into the permafrost. Above them, concrete girders resting on the foundations at a distance of at least 1.5 meters above the ground. Such a foundation creates a layer of air that insulates the heat generated by the structure from the frozen sediment. This prevents the permafrost from heating up.
People have been building on permafrost for thousands of years. When they started to build these homes, they had no idea that this permafrost could ever thaw, and it looks like it's starting to do so in many places.
The result is that formerly rock-hard subsoil becomes muddy and soft, and the buildings on it collapse, sometimes with catastrophic consequences. In 2020, a tank at an oil storage facility in Siberia collapses. Over 20,000 liters of diesel spill out, contaminating nearby rivers and lakes. The only chance to prevent such incidents in the future is to keep the ground artificially frozen with the help of technology. To do this, engineers use a technology that was first invented in 1849, so-called thermosiphons. Thermosiphons consist of metal pipes several meters long. At one end is a radiator, a metal body with a large surface area that is extremely thermally conductive. The tubes contain ammonia, liquefied under pressure. The thermosiphons are anchored several meters deep in the ground. If the temperatures in the permafrost are too high, the ammonia in the pipes begins to boil due to the heat. It rises as vapor, extracting heat from the soil. It releases this heat into the air at the tip of the pipe. This causes it to condense again, drip downward, and heat up again. A cycle that runs completely self-sufficiently and requires no electricity. This technology keeps the Trans-Alaska Pipeline from collapsing, for example. The pipeline transports 160 million liters of oil from the Arctic to the southern coast of Alaska every day. That amounts to 17% of U.S. production. Thermosiphons are inserted in the ground next to each of the pipeline supports, keeping the permafrost frozen and the pipeline stable. Thermosiphons also cool the trackbed on the Tibet Railway, which was completed in 2005. Engineers have installed more than 10,000 of the cooling metal pipes along the rails. The 3-meter-high railroad embankment consists of football-sized chunks of stone that are stacked on top of each other without mortar. The wind passes through the loose stone layers, cooling the ground in the process. Thanks to the combination of the two technologies, the Tibet Railway manages a top speed of 100 kilometers per hour, a world record for a railroad on permafrost. Modern technology can keep individual buildings and infrastructure from collapsing, but it reaches its limits when it comes to large areas.
It's just quite simply not possible to keep entire areas of tundra frozen in this way. It'd be far too expensive. These kind of technologies are incredibly expensive. They also cause a lot of damage to local ecosystems, to the flora and fauna of the region, and that needs to be protected as well.
In the mid-1990s, a Russian scientist launches an experiment to explore how large areas of permafrost can be permanently preserved, the Pleistocene Park. The idea is to restore the original Arctic ecosystem and thereby save the permafrost over a large area.
So as a first step, he was collecting animal bones and remains all across the tundra to reconstruct how the animal world looked like back in the days.
The scientist then settles large grazing animals, such as bison, wild horses, and elk, on nearly 150 square kilometers. These animals most resemble the animals that lived there during the last cold period 15,000 years ago. The theory: in winter, animals trample the freshly fallen snow. By doing so, they destroy the insulating effect of the snow, allowing the ground to better freeze solidly.
The idea is that the animals will trample the ground down, and that basically makes the ground thicker, more compact, and makes it a better insulator. But then also they keep the vegetation low, and that helps to reduce the amount of solar radiation that's absorbed, thereby reducing the temperature at the surface and helping to preserve that permafrost layer.
Initial long-term measurements show that inside the park, the thawing process progresses much slower than in the areas outside. Despite this success, there are doubts whether this principle would also work outside the confined area.
Unfortunately, there is no technology available to us today to prevent the permafrost from melting. This is a big problem. It ultimately has to do with the climate change on Earth. And if we could prevent that from happening, then we would slow down the permafrost melting.
Not until we manage to prevent large-scale thawing will we tackle another problem: the deadly dangers lurking in thawing soils. In 2016, an anthrax outbreak occurred on Russia's Yamal Peninsula, a disease considered eradicated in the area for the past 70 years. The anthrax pathogens survived in the permafrost for many decades. When the ground thaws, they become active again. Reindeer then transmit the dangerous bacteria to humans. One person dies as a result of the outbreak. 90 need to be treated in hospital.
In this case, we were lucky because this was a very local outbreak and the authorities reacted very quickly. Also, anthrax is well known at this point. But there could be other things lurking down in the permafrost that we have no defense against.
The only way to prevent a pandemic from the ice is to stay one step ahead of the pathogens. The first thing to do is locate the areas where the ground is thawing. This is where high-tech steps in, what's known as LiDAR. LiDAR's three-dimensional laser scanning is much more accurate than radar, and it can also see through tree canopies and vegetation. The same system is used in self-driving cars. It ensures that the cars can detect even the smallest obstacle in their surrounding environment. LiDAR scans the environment with a beam of light. The system transmits up to 150,000 light pulses per second and detects the light reflected from the objects. A sensor then measures the time between the emission and the return of the laser pulse and uses this to calculate exact distances. This produces a precise 3D real-time map of the surroundings.
Scientists use atmospheric LiDAR instruments to measure the concentrations of CO2 and methane in the atmosphere. We know that the concentration of both gases have doubled since the start of the industrial age.
As the ice thaws, we get more greenhouse gas emissions. That leads to a warmer average temperature in the Earth, and that leads to more ice melting and potentially further carbon dioxide and methane emissions.
The next technological revolution for detecting thawing permafrost areas is Merlin, a 400-kilogram research satellite. Also using a LiDAR system, it measures methane concentrations in the atmosphere, providing precise information on the state of all permafrost areas worldwide. If a LiDAR system locates an area where the ground is thawing, scientists take soil samples there and analyze them for viruses and bacteria. Especially bacteria can spend thousands of years in a kind of hibernation and multiply after thawing without any problem.
Scientists think that there's a danger that when these long frozen bacteria meet present-day bacteria, they could exchange genetic information, leading to the formation of new sort of superbacteria, if you like, that have antibiotic resistance and we don't really know how to fight. And that would be a real headache for modern medicine, basically.
This makes it all the more important to be well prepared. Therefore, researchers open the cells of bacterial finds from the permafrost and extract the DNA. The subsequent analysis determines if it is a previously unknown, highly contagious species.
So far, we haven't found any killer viruses in the permafrost. But that we haven't found any doesn't mean that they're not there.
The interim conclusion. Up till now, thanks to state-of-the-art technology, we have been able to cope well with the consequences of thawing. However, there is still no technical solution to the basic problem itself, the thawing of the ground. The only way to prevent this is to stop global warming. Chapter 3 is about one of the biggest problems facing humanity, the melting of the polar ice sheets in Greenland and Antarctica.
When ice sheets melt, the water from these gets basically deposited in the oceans. This will have several effects. Within the oceans, it will change the salinity of the ocean water. It would make it less salty. And that changes the whole living ecosystem of the areas in the ocean. Secondly, as ocean levels rise, the whole planet has more ocean surface area than land. And that will increase the darkness or the albedo of the planet and therefore lead to warming up further because more solar radiation will be absorbed by the oceans.
The weight of all man-made materials on Earth, from paper clips to skyscrapers made of steel, concrete, and glass, amounts to 1.1 trillion tons. That alone is a gigantic sum. In the last 20 years alone, roughly 18 times that amount, some 20 trillion tons of ice, has been lost. Ice sheets consist of frozen fresh water. If too much of it gets into the sea, it changes the ocean salinity and thus the ocean currents. One of the most important ocean currents for Europeans is the Gulf Stream. It is considered Europe's heat pump. It transports warm water from the Caribbean to Europe and thus ensures a warm climate. The Gulf Stream already stopped once. It happened about 12,000 years ago in the transition from the last cold period to today's warm period, when it was just starting to get warmer again. It was triggered by huge amounts of meltwater. The result, average temperatures in Europe dropped to -4 degrees Celsius, about 5 degrees less than today. At that time, it took almost 1,000 years for it to slowly warm up again.
So if the Gulf Stream dies out today, then the climate in large parts of Europe or the entire Europe would change drastically. So our living conditions would change and temperatures would go down considerably and leave Europe probably to an Arctic climate.
That makes it incredibly important to monitor how much ice is melting so that we have a better idea of the risks of these sorts of events happening, basically.
The best way to keep an eye on the gigantic ice sheets is from space. For 20 years, the satellites GRACE and GRACE-FO missions have been orbiting the Earth, measuring the ice sheets using what is known as the gravimetric method. This process uses the Earth's gravitational force, because gravity varies depending on temperature and the nature of the Earth's surface.
You can detect moving ice sheet even if the movement happens under the surface. You can detect it on space, not by looking at it, because it's hidden under the surface, but by measuring the gravity field around these areas, because water and ice have different gravity. If ice melts, the gravity signature above the region will change, and this is something we can detect with satellites.
The two satellites fly around the Earth, one behind the other, at a distance of 200 kilometers. They continuously send microwaves to the Earth and receive what is reflected back. This is how they measure their exact distance from the Earth's surface. If one of the satellites is impacted by just 1/10 of the diameter of a human hair, more than the other, it is immediately noticed and the difference is reported. Greenland is particularly affected. There, ice melt has tripled in recent decades. One of the main reasons, the warming of the Arctic Ocean by almost 1 degree per year. The warm seawater is gnawing away at the edges of the ice. Scientists therefore want to launch a gigantic pilot project there to protect the ice. The idea, a gigantic underwater wall at the entrance to a fjord. It would form a barrier between the warm seawater and the ice masses. The wall would be 5 kilometers long and 100 meters high. The building material would come from the seabed, stone and sand, which is then consolidated with concrete. The wall should then prevent the warm water from reaching the ice. An enormous undertaking with a chance of success. Computer simulations show that the wall would reduce ice melt by 80%.
It's hard to imagine that any man-made object could withstand these enormous forces of nature.
That's why planners have an alternative proposal ready. The idea is to build a 300-meter-high artificial embankment on the seabed, with mounds heaped up from the sea floor. They support the ice from below and thus prevent large pieces of ice from breaking off. This allows the ice to grow back more quickly. These mounds are only 1/3 as effective as the wall, but they are much easier to build. But
These hills on the seafloor are right now just a concept, an idea. Nobody has built them yet.
another idea to save the polar ice sheets is based on what is known as albedo. The term stems from Latin and means whiteness. Albedo is the reflectivity of a surface from sunlight. The darker the surface, the lower the albedo, and the more sunlight is absorbed.
Over the past 4 decades, we've lost something like 95% of the oldest, most reflective ice. And that's a problem because of the albedo of this. So this is how much of the sun's energy is reflected back into space. So if we lose the most reflective ice, then generally we absorb, or the ice that exists absorbs more sunlight, and that tends to result in a higher temperature, leading to further ice melting and further increase in this absorption or albedo.
This is exactly where the idea of an American scientist comes in. Microscopically small glass spheres are supposed to increase the albedo of the ice again. The spheres are made of silicon, a naturally occurring semi-metal. Spread over ice floes and sea ice, they are supposed to reflect even more sunlight and thus slow down melting. Initial tests of the material are already taking place in Alaska and Canada.
You can argue whether it is a good idea to introduce something into the ocean which is artificial, and this could harm the nature there.
Other scientists want to stop solar radiation before it even reaches the Earth's surface.
The idea is that balloons or aircrafts would release sulfur particles into the atmosphere, and those aerosols would reflect the sunlight from the sun radiation to the Earth's surface to take away some of the warming that comes from the sun. This way, the climate would cool down, and the glaciers would hopefully melt less. So that could be, in theory, a technical solution to stop the melting of the ice.
A natural hazard from the year 1816 shows just how dangerous. A volcanic eruption in Indonesia releases 130 megatons of sulfur into the Earth's atmosphere, barely allowing solar radiation to pass through. Throughout Europe and North America, temperatures drop by several degrees Celsius. For fear of triggering a similar scenario, the introduction of sulfur particles into the atmosphere has been banned worldwide to this day. It's an approach that is already technically feasible today. Iceland is currently home to the world's largest CO2 storage facility. The plant consists of 4 containers, which are equipped with large louvers. Huge fans suck the air inside the containers where the CO2 is filtered out and recovered in a collector. The system then releases the carbon dioxide through heat and dissolves it in water. For storage, the plant pumps this water into the earth up to 1,000 meters deep. Porous rock is deposited here, which contains minerals such as magnesium, calcium, and iron. Through contact with these elements, the carbon dioxide practically begins to fossilize, forming so-called carbonates. This process takes up to 2 years. The advantage of this process is that under normal conditions, the carbon dioxide remains stored in the stone for all time. At full capacity, the plant pulls around 4,000 tons of carbon dioxide out of the air every year. That is equivalent to the emissions of 870 cars. Even if these are only small amounts, it shows that the technology works. The next step is storing carbon dioxide in empty oil and gas fields under the sea. Beginning in 2032, this will happen in the North Sea off Norway. Pipelines will transport the gas directly from factories in Germany and Northern Europe to the empty oil and gas fields. There it will be compacted under pressure and pressed into the rock strata and fossilized. To finalize, thanks to satellites and the latest engineering and measurement technology, we are currently well equipped to deal with some of the consequences of ice melt. But as for the big picture, we still don't have a real solution. The only option is to continue working to find ways to prevent global temperatures from rising even further.